Hi there, welcome back to the channel. Welcome to the third video in the Grundig 2140, and by popular request, this is the cat. All right, you guys happy now? I've had a lot of requests for this guy to come up on the channel. Okay, enough of that. Anyway, this one is where I get into or complete the audio section of the radio. I do go into quite a bit of schematic detail, and what I'm going to do for those who don't like that is when that starts, I'm going to put a timestamp where you can jump to. I will not be offended, believe me. Just jump ahead where I get back into the practicalities of the restoration. Yeah, I do some testing of the EABC80 tube because I had to use that as well, and I'll use any opportunity I can to try out the tube tester. And of course, what is this guy doing? He's making himself far too comfortable around 300 volts, but I hope he doesn't learn the hard way. Anyway, stick around. I hope you enjoyed the video. But before we carry on, I just want to thank the sponsors of this video, PCBWay. If you come to the website and you want to see some of the projects that I've done and use the PCBs that I've actually produced, you go into the shared section, and here you can search for the PCBs or the PCB projects that I've done. Not only mine, but probably thousands of other projects that other users have created and have made the PCBs available for you if you'd like. One of the things that really attracted me to them is that your PCBs can be extremely well priced and with very fast turnaround time, and you can do a simulation exactly what you want on your order, so there's no doubt when you're working on a project how much you're going to spend on it. The other area that's looking interesting to me is the CNC section, where you can do CNC milling by sending up a file in any of these formats. And again, you do the same thing. You tell them what material you want. So here's another example. You can get your 3D printing done with them. But overall, their products and capabilities are endless, and their prices are extremely good. So whatever you need, go over to the website, and I'm sure you'll find something for your needs. Let's get back to the video. Okay, what have I done here? Well, I've actually done quite a bit. I've done the entire audio section. I've got the audio pickup selected over here. I'm going to demonstrate the result, and then I'm going to go into the detail and show you what's been done. As you may remember, the last video, I'd found that the EL84 was extremely gassy, so I've got a new one in there. It's not new, it's a used one, but it's one of the ones that I checked on my DIY tube tester. And this was actually the readings that I got. I did these little cards, and the reason I did that is because I wanted to be able to monitor or record the results on the particular tube. Just out of curiosity, I've got this the Funke section and then the typical operating conditions section over here. This Funke section means it's either questionable or good. As you can see, in this case it's good, and it's good because it reached 41.1 milliamps when the limit of good is 27. That just gives me an indication. Then down here, I've got the typical operating conditions. I've got, this is at the 250 volt setting for the EL84. It reached 43.8, whereas the typical operating condition says 48, which is pretty close. The S for this thing is 10.1, whereas they say 11.3, again, pretty close. And the mu is 18, where they give us 19.5. So this tube is very good in my opinion. And let me show you the result on here. I've got a 1 kilohertz signal coming into the back there. Notice it's the input pin of that DIN, not the output. The output is if you want to take it to a tape recorder. And I've got it coming out the speaker, going to my dummy load over here. I've got speaker selected, and I'm monitoring this on the scope. So there we go. Right, let me put this on dummy just so that we don't have to listen to it. Obviously the impedance of the dummy is slightly different to the speaker because you get a bit of a jump on there. And if I go up, I have to change the scale. I want to see where it starts clipping. Actually, I've got full gain over here, full volume, and I still haven't clipped. So I'm going to drop the volume down. I'm going to increase the input signal to 400 millivolts. See if we can get it to clip. Well, it's distorting a little bit there. That's already a slightly distorted sine wave. but it's not clipping yet. So let me give it another. That's now 500 millivolts input, and yeah, okay. That starts getting ugly, sort of there-ish. That's already quite distorted. Let me go down a bit. And if I look at this thing, it's at 2.2 volts. It's probably more like 2 volts acceptable distortion. Now remember, this is tube distortion, so you should get all those warm, fuzzy tones coming out. You know, they go a bit crazy with that. But yeah, that's where we are. Now, what exactly have we got in our audio section? In very, very simplistic terms, this is what we have. We have an audio selector. It's a switch, and you're selecting between various audio sources. Now, in our case, we have pickup or external, the auxiliary. We've got AM, and that would bring in any of the audio coming from whichever AM band we're listening to, whether it be long wave, medium wave, or short wave. And then we've got FM. So we would select that, and that audio would ultimately get to a volume control. The level of the volume control sets your volume, and that would go to a preamp section, which is incredibly simple in this radio. Very, very simple. It's one triode, and we will see that. And the preamp section then takes you off to the power amp. Now, a few things happen in the meantime, and that is that you have a tone control. You have tone shaping that happens between the preamp and the power amp. In this radio, it's a very, very simple tone control. Then it gets to the power amp, and that audio is induced on the primary of the output transformer, and it's reproduced on the secondary that then goes to the speaker. However, as with many of these radios, the audio output, the speaker output, is also tapped, and that then comes back, it's fed back to another series of tone shaping stages, and from that it then gets to affect the input of the audio. The way they've done it is they've tone shaped in two ways. One is the actual signal between the preamp and the power amp, and the other one is the tone content, the tonal content of the actual signal that goes across the volume pot. Now, volume pot is very simple. You put a signal at the top, and you usually chuck this at the bottom to ground, and the voltage over here is induced across a resistor for all frequencies that are in the audio. However, if you mess around and you add or subtract certain frequencies to the bottom over here, what you're actually doing is either adding or subtracting the effect of those frequencies across the entire volume pot, which will then affect the frequencies that go in here to the preamp. That's how you do this feedback system of tone shaping, and it works very, very well. So that is our system, and what we looked at last time was really this. And again, right away we found a problem with the biasing of that tube. And basically, the audio section that we're looking at is this thing over here. This is the entire audio section. If you take away all the superfluous stuff, all the parts of the drawing that have nothing to do with the audio, this is what you're left with. You're left with B+ coming in here. It's going through the transformer as we discussed. Here's our audio power amp. Here's our audio preamp. Here's our switching with the volume control over here. And the switching then from here takes the selected switched audio to the top of the volume pot. The tone shaping feedback comes from here, from the speaker, all the way back through here. As you can see, there is also a loudness effect. It's a pseudo loudness effect, which is a tap from the volume pot at a certain point in it, which then goes through basically a high frequency bleed circuit. So some of your high frequencies can escape through this 3.3 nanofarad capacitor. If you can imagine, the DC will not go through a capacitor. DC is zero hertz, which means that the higher the frequency, the more easy this path becomes for that tone. So that tone bleeds out, and the actual result is that your preamp gets a warmer tone or warmer signal to then amplify and pass through your circuit. But that is our audio system in a nutshell. Let's have a look at how the switching works. If you select FM over here, that's what's coming through. FM signal comes straight down here, through there, through the capacitor, which is open to audio signal, through there, up and out to the volume pot. Very simple. If we select medium wave, you see that? That switch flicks to medium wave. this is what happens. Your AM signal gets passed through to the volume pot over there. Now, what happens if you select? See that? That's a shortwave switch. If I activate shortwave, that's all that it does, and my path is still open to the AM signal. Now look what happens when I select long wave. Don't forget, I was there. That's shortwave off, that's shortwave on. Long wave is like this. It just goes through a slightly convoluted path, but it does the same thing. Our AM comes in up there, through there, up there, and boom, it goes to the top. So all we're left with is the pickup, TA. And that's what happens when you select TA. You actually activate two switches. Your long wave, which is already switched on, or rather your short wave, which is already switched on, and your long wave. That's what you do. Your pickup comes through and it goes to the volume pot. Simple, right? And brilliant. I like this idea. I like looking at it like this because it makes it a lot simpler. Now, if we look at the power amp stage, this is really what we've got. You've got your B plus coming to the top of the tube. You've got your screen grid voltage coming to here, slightly lower than your B plus, than your B1 plus. You've got your cathode resistor, cathode bypass, and there's your audio coming in through that DC blocking capacitor. And your signal over here is reproduced inverted over there. Whatever goes up here goes down there. That is your power amp. And it's exactly the same as you would get in a textbook case. This is a textbook drawing of a power amplification stage. The only difference here is they put the B plus coming in here, and they've got a resistor, which we've also got over there. The resistor brings that voltage slightly down to another filtering capacitor, which is that one over there, and that becomes your grid 2 voltage. So it really is a textbook case. Very, very simple, and as we found, we replaced that guy and that guy and that guy. Now the preamp is equally simple, and the only reason it looks complicated is because we've got all the tone shaping involved. This is the preamp stage over here. Now what we have different, or what we've added on, is this resistor, that capacitor, and this section over there. What is this doing? Well, this is taking B plus from there, B2 plus, through a resistor to another filter capacitor. This is another small filter capacitor, because this is not much current going through here, so you don't need a very big filter capacitor. So you're creating a third B plus. I call this B3 plus. And then you've got your anode, your plate resistor over here, 220K, across which the audio is generated as the load. This is the load of this triode. And we're using just the triode in this case, which is that anode, that grid, and of course the cathode, which is common to the diodes that are in there as well. And again, the audio is coming in here into the grid through a DC blocking capacitor. This triode is actually biased. It's grid leak bias. The biasing of this cathode, which it needs, is created by the electrons that actually do hit the grid. And that, of course, creates a voltage because it's a very small amount of current, but this is a very big resistor. So a small current, big resistor gives you reasonable voltage, whatever bias voltage this needs. I'm not even sure what it is. I think it's about, 3 volts or something? But here we have it. This signal that comes in this case, I've drawn it inverted, is also inverted over here because I had drawn inverted over there. So I've drawn this like that, down, up, and down. And here it goes up, down, and up, because it does invert as well. Similarly to the pentode over here, the triode does exactly the same thing. So this is our preamp. Everything else that's on here is really volume control, switching, and tone. This is our textbook triode amplification stage. You've got the blocking capacitor coming in here. You've got the grid leak over there. You've got your triode, and you could also have you can sometimes have a cathode resistor on here if you want to do this as cathode bias. But in this case, this would be a very big resistor. You've got your load resistor, and there's your audio coming out. Textbook, okay? Now, the tone shaping that I mentioned is interesting because this is what you do in a textbook tone shaping situation where you just want to cut the treble. You've got your audio signal coming out here, has, let's call it, all the frequencies from 20 hertz to, I don't know, it won't be 20 kilohertz, but it could be, okay? Now, that signal sees a capacitor, and it says, you know, I'm high enough to get through. You know, I can get through there. You know, the big fat bass sounds, they look at this little gap of the capacitance, they say, I can't get through. I won't even try. But the higher the frequency, the easier it is for it to actually get through here. So some of it starts getting through. And of course, at high frequencies, all of it can get through. It gets through here, but then it meets a resistor and it goes, whoa, wait a minute. That path to ground is not as open as I thought it would be. How open is it? Well, I can determine how open it is because I can change it. This is my tone control. So if I make this pot down to 0, every single frequency that can get through here will use this as an escape path to ground and not get amplified, which means I get more bass. If this thing is up near to 500, I create a shelf, I create a cutoff that's not as short, as tight for, or doesn't encompass as much of the lower or mid frequencies as it does the highs. So that tone becomes more treble rich. So this is our tone control in a typical textbook situation, which is exactly what we have here in our circuit. That's all we have for tone. Adjustable tone control, that's all we have. What we do also have, though, is this. We have the feedback circuit. And the feedback circuit, again, is interesting because, well, if you look at it, you've got audio coming here. This is our music button, and there's our medium wave button. As long as medium wave is on, it's not FM. That's this condition of that switch. It only switches open. This will only open when you hit FM. Otherwise, it's called medium wave. It's on the medium wave switch, but it's for the AM, okay? When I hit FM, this thing opens. When I don't, I've got audio, I've got AM audio, and there's a 150 ohm or 150 nanofarad capacitor that comes all the way from the output through this resistor, which allows a lot of the high frequencies here at the speaker to escape to ground because I don't need to hear them. Medium wave does not have high frequency content, so let it go. You know, why waste your ears on it? Why waste your speaker on it? When I choose FM, I click it and that opens, so that escape no longer exists, which means that we now have more treble coming through. But I've also got this music button. Now this music button is one that if you press it, it's music. If you close it, it's music. If you open it, it's speech. And that's what happens when you activate this button. You either have some of these frequencies getting through, straight through to the bottom of the spot, or they have to go through this resistor. Okay, actually that capacitor as well. But this resistor is shorted when you activate this between music and speech. And in one of those conditions, treble gets through, and in one of them, less treble gets through, or less audio gets through. At this point, there's no shaping. But there is here, this will allow more high frequencies to get through, but this is just a resistor, so you're shorting this out. If you short this out, that all the frequencies just get through there to the bottom. And what this does is it's creating negative feedback without discriminating between the frequencies, if you have this shorted out, okay? Negative feedback without discriminating on the frequencies. So all the frequencies are subjected to negative feedback over here because this bottom of this pot is not directly connected to ground. There's actually a 560 ohm resistor between it. It's basically subtracting from the total signal across this pot. In this case, when this is shorted on all frequencies. Now, if you open this, then what have you got? Well, you've got all frequencies trying to get through, but the high frequencies get through a lot easier. And if the high frequencies get through a lot easier, boom, they subtract more, okay? So that means that would be better for speech, for example, where your high frequencies are not that important. So again, you've got this tonal shaping. Over here, you've got that pseudo loudness control that a lot of these German radios use. And what happens is when you bring this volume down, some of your or more of your high frequencies escape, so that the volume that's taken off there, the part or the portion of that voltage, of that signal that's bled off to the preamp, is less trebly. So the whole sound becomes more bassy and becomes warmer, okay? And of course, there, the output of this preamp, you've got your tone control. We've just got this in reverse to the textbook case I showed you. You've got the 1 meg pot over there, and you've got a 10 nanofarad capacitor also to a negative feedback, because this signal here is inverted. So if it comes back, it's negated. Okay, that is our audio circuit. Well, that is definitely enough lecturing for one video. I think from now to the end of this video at least, I think we'll stick to the practicals. Here we have the radio. I haven't shown you yet what I've done on the remaining part of the audio section. I mentioned obviously the output stage, new tube on there, but I also have another tube here. This is the ABC80, the triode of which is the preamp for our tube. So what exactly did I need to do? Well, now that I've got a tube tester, first thing I did was test that tube, and I want to show you the result. This is like somebody who buys a blender and all he can do is make cakes. Let me show you. Here's our EABC80. Now this tube has got one triode and 3 diodes. I have not yet figured out how I'm going to test the diodes because it needs various AC voltages, but I won't worry about that for now. I want to test the triode. So what I'm going to do, this is still off, this is in the upright position. I've got the plug for it. It's the ABC80 triode. It's wired for that according to the requirements, according to the pinouts. I don't have the conditions here at the back yet because I'm building another set of 5 like the other one, which will clip on the back with that magnetic strip. But I'll tell you what they are and I'll show you. I'll put this on the side. And if we look at the card, the Funke card, it tells us that for a questionable tube, we need more than about 1.4 milliamps. For a good tube, about 2.2 milliamps. So what I'm going to do is put this on 20 milliamps for now. I will not power it up because what I still need to do here, well, actually I can, just to see if there's any leaks, any shorts. There don't seem to be, but what I need to do is give it 150 volts. For the Funke test, this one doesn't count. It's just, give that. This is supposed to be 150. With the multi-turn pot, it's a lot easier to get there. It takes a bit longer, but it's a lot more accurate. Here we go, 150 volts. As I said, that doesn't count. Now, if we put this on test, and I go down to 0, what I expect is one of those readings I've told you. Now, I believe the tube is heated up enough. 4.1, well, 4.1 is way up there. Way up there, actually, quite high. Remember I said better than 2.2 or something like that? This is a good tube, or good triode anyway. Let me give it a gas test. No, we don't seem to have a gas problem. Okay, so let's put this on the typical operating conditions, and that would be 250 volts. And at -3 volts, we expect 1 milliamp. So this goes up to 250. And at -3 volts, I've got to put this up. So let's hit it. At -3 volts, I expect 1 milliamp. No, I don't quite get it. Where do I get 1 milliamp? I get 1 milliamp at -2.7. That's not bad. That's not bad. So it's not quite operating according to the typical operating conditions. I should get 1 milliamp over there. Okay. But it is working. But what about the other stuff? What about the S? The S is 1.2 milliamps per volt. So what I'm going to do is, let me put this on 2 milliamps. It's not going over 2 milliamps, I don't think, so we're good. So if I go to, what is that, -3, I got 2.607. So if I go to -2.5, -2.5, I get 1.36, and -3.5. I've got to write this down because I forget. So what did I say? Minus 2.5. I'm going half a volt below. Minus 2.5. 1.37 milliamps. If I go to minus 3.5, .23. That is 1.14 milliamps per volt. Now they tell us 1.2 milliamps per volt. That is pretty close. 1.14 versus 1.2. That is, near as damn it, exactly right. Okay, now I want to try the other thing. So we're at, again, let's go down to minus 3. Minus 3.6. Now if I go to minus 2.5 again, .38, and now I want to get this down to 0.60. I've gone down half a volt. .60. That is about there. 214. So 214. So from 250. We've dropped 36, but that was for half a volt. So for 1 volt, that means our mu is 72. What do they tell us? 70. Brilliant. Brilliant. I'm happy with this tube, or at least I'm happy with this triode. The triode seems to be perfectly fine. But you see, it wasn't that difficult to get those readings. I keep forgetting sometimes what I'm doing when I'm trying to work out the mu, you know. But once you get used to this, it's actually quite easy. I'd like to put this back on 200 because worst case, this thing will be a high current tube. So we're good. This one is not that hot, so I can take it out and I can just put this back on top of the cupboard again until the next tube needs testing. Great stuff. Now, if we look here, we don't really see much new, do we? We can see a few new caps. That's one there, that's one there, that one there, that one there, and I think that's about it. What is that? 1, 2, 3, 4 caps that I replaced. If you look at the schematic, exactly what do I see here? Here's the full schematic corrected to date. And what we have here is, we already had that one. So 1, that we already had that one too. So 1, 2, 3, and that one there, 4. That's it. Now we've done the entire audio section from the input, from the auxiliary input at the back, from the switching of all the audio, through all that stuff, and it goes into the EAPC80, which is nice and seems to be nice and strong, and off it goes into the power amp section. So that is our audio. That's our audio done. And yeah, it's, well, the explanation is a lot longer than the work done. But that's the nature of the beast, and this is the way I like to do these things, and it seems to be the way you guys like it, because you keep telling me to do schematics. Somebody else says that I'm putting them to sleep, but hey, if you don't enjoy the video, you can use it to cure insomnia. I know I do sometimes when I'm trying to do research. When I try to do research, I put my videos on 1.5 times speed, and usually if I'm sitting down, I fall asleep. So yeah, okay, well that's where we are right now, and that's where I'm going to stop for now. I'll be carrying on with my usual routine, which is now to move on to the radio section. The first one will be AM, and that'll give me a chance to test the, what is that? That's the EF89. I can actually put this one back, can't I? I've also cleaned that part of the board already. So there's the EF89, which will be tested. I've got a little plug for that as well. I've got a plug for the ECH81 heptode and triode, so I'll be able to test those in my tube tester and see how that works, and then see what the alignment's like, and actually see if we've got reception. I have no idea at the moment, but well, I do. We heard something, didn't we? We just had an audio problem. So I expect this thing will be fairly straightforward, fairly routine. But yeah, if I didn't like routine, I guess I would give this up. Anyway, I want to thank you all for your attention, and I want to ask you, please, if you've enjoyed that, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and on PayPal. Links are in the description below. Thanks for watching. Bye for now and stay safe.